Now again, this is about the mean and variance of the sampling distribution. And our memory verse is found in Joshua 18 verse 4. It says, Joshua said, select 3 men from each tribe, and I will send them out to survey the land. They will return to me with a written report of their proposed divisions of their inheritance. At the end of this lesson, you'll be able to find the mean and the variance, the sampling distribution. Also, define the sampling distribution of the sample mean. Illustrate the central limit theorem. Define sampling distributions of the sample mean. And solve problems involving sampling distributions of the sample mean. It may sound too long because we have so many objectives, but mind you, this is a very simple topic as long as you remember what's in chapter 1. Now, I think you already have your venture activity in the mole. The question is, we need to solve the mean and the variance of the probability distribution. And that's a very brief wrap up of last meeting's topic. Now, last meeting, we end up with this table. Let me show you. In step 4, we have the sample mean, the frequency, and your P of X. That is where we will continue today. Now, how to solve for the mean and the variance of the sampling distribution. Step 1, we need to solve for the population mean. How to solve for the population mean? We need to add all the X and divide by the N, by the number of entries. And step 2, solve for the population variance. How to do it? Observe your sample mean, you subtract it with the population mean, that's the mu, you square it, you add all in the column, then divide it by N. Step 3 is the same as last meeting. We need to list all possible samples. Step 4 is still the one last meeting. We need to construct a table for the sampling distribution of sample means. Then step 5 is where we start today. We will multiply the sample mean by the corresponding probability. This is the X times P of X. Step 6, we'll add all in the column. That's the mean, remember? In step 7, we will multiply the X times P of X column by the X column again. We'll add them all. And in step 9, we'll solve for the variance and the standard deviation. Now let's start. For example, in example number 1, we consider the population 1, 2, 3, 4, and 5. Suppose samples of size 2, it means 2 elements per group, are drawn from this population. Describe the sampling distribution of the sample means. Step 1, we'll solve for the population mean. What are we going to do? We'll add the given numbers. So 1 plus 2 plus 3 plus 4 plus 5, that is 15. Divided by, how many numbers are there? There are 5. So divided by 5, the answer is 3. So our sample mean is, our population mean is 3. Next, in step 2, we will solve for the population variance. Now, how to solve for the population variance? Remember that These are the given numbers, right? That's 1, 2, 3, 4, and 5. In the second column, that will be x minus the population mean. Remember, our population mean is 3. So 1 minus 3, the answer is negative 2. 2 minus 3, that's negative 1. 3 minus 3, 0. 4 minus 3, 1. 5 minus 3, 2. Then in the next column, we will square it. The answer in the second column, square it. So negative 2 squared, the answer is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Next, let us have the sum of this one. You add all numbers in this column. We have 4, 1, that's 5, plus 1, 6, plus 4, 10. So our summation is 10. Now, how to solve for the population variance? Here's the formula for the population variance. So the summation, that's 10, divided by how many entries are there? There are, wait for a while. There are 5 entries, so divided by 5. So our population variance, or our sigma squared, is equal to 2. That is why, remember again, our population mean is 3 and our population variance is 2. Now, let's have the next step. The next step is based on our lesson last meeting. Remember, we have numbers 1, 2, 3, 4, and 5. And we will consider samples of size 2. Now, let's have step 3. Let's have 5C2, right? There are 5 entries and with sample size 2. So if you'll have your calculator, 5C2 is 10. So we will have 10 possible samples. Now, how do we list the samples? Let's go back to our technique last time. Remember, we have numbers 1, 2, 3, 4, and 5. Size 2. So let's have 1 and 2 first. Next, 1 and 3. Next, 1 and 4. Again, these are combinations. So we could not have 4, 1. Because 4, 1 and 1, 4 are the same. Then 1 and 5. Next, let's start with 2. 2 and 3. Next, 2 and 4. Next, 2 and 5. Let's start with 3. We have 3 and 4, 3 and 5, and the last is 4 and 5. If you count, there are 10. Then let's have the mean. How do we do this? You add the numbers. 1 plus 2 divided by 2, because there are 2 numbers. So that's going to be 1.5. Next, 1 plus 3, that's 4, divided by 2, that's 2. Next, 1 plus 4, that's 5, divided by 2, that's 2.5. Until you arrive in the last one. 4 plus 5, 9, divided by 2, that's 4.5. Next, in step 4, you need to arrange your mean from the least to the greatest. So let's go back to our material. So we now arrange them from 1.5 to 4. Next, they say you really need to be very careful with this one, because if you'll get an error in step 3, everything will be erroneous to the end. So you need to be very careful. Next, let's have the frequency. Example, how many times did you see 1.5 in the mean? Just once. So the frequency is 1. How many times did you see 2.5? You have 1 and 2, so twice. So you write 2 in the frequency. How many times did you see 3? They're here. 3, 1, and 2. So twice. So the frequency is 2. In the third column, P of X, that is, remember there are 10 entries, right? In the mean on top, there are 10 possible samples. So we'll have 1 divided by 10, that's 0.1. 1 divided by 10, 0.1. 2 divided by 10, that's 0.2. And if you add this column, you will have what number? You will have the sum of 1. Next, let's go to steps 5 and 6. Let me start in step 4. Now, how do we solve for the mean and the variance? In step 5, you need to add another column. Remember chapter 1, lesson 3. Let's have x times p of x. What do we do? Remember, this is our x. We will multiply these two columns. So 1.5 times 0.1, that's 0.15. Next, 2 times 0.1, 0.2. This is 0.5, 0.6, 0.7, 0.4, and 0.45. Next, how do we solve for the mean? To solve for the mean, we need to add this column. Remember? If you add this column, the answer will be 3. And remember, this is the mean. So, how do we denote it? X bar of X bar. That is how we read it. The mean of the sampling distribution. The mean of the sampling distribution is 3. Then, we need to compare it with our population mean. Remember, we have solved a while ago. Our population mean is 3. So we say that our population mean, we say in words, our population mean, or in symbol, is equal to the mean of the sampling distribution. If we go back to our material, it's stated there. Was there? Here, we compare, you say, the mean of the sample means, which is 3, is equal to the mean of the population, or to the population mean. That is your first conclusion. Next, let's go to the variance. How do we solve for the variance? Let's add another column, and let's name it x squared times p of x. So it means that you will square this one and multiply by p of x. Or another is, you multiply the x of p of x column back to the sample mean again. So we have 0.15, 1.5 times 0.15. The answer is 0.225. Ma'am, what if the answer is too long? You could have up to 3 or 4 decimal places. The more decimal places, the more accurate the answer is. Next, 0.2 times 2. We have 0.4. 2.5 times 5. The answer is 1.25. Next, 3 times 0.6, 1.8. 0.7 times 3.5. The answer is 2.45. 4 times 0.4, that's 1.6. 4.5 times 0.45, the answer is 2.025. Then we'll add this column. If we are going to add this column, the answer will be 9.75. Now, how do we solve for the variance of the sampling distribution? To solve for the variance of the sampling distribution, actually it's still sigma squared. That will be the summation of x squared p of x minus the square of the mean. So this is 9.75 minus 3 squared. So our answer is 0.75. This is now the variance of the sampling distribution. And if you want to solve for the standard deviation of our sampling distribution, what do? We simply find the square root of 0.75. Now, how do we compare it? Remember, what is our population standard deviation? The one in step 2. The population standard deviation is 2. So it means that the population standard deviation is greater than the variance of the sampling distribution. How do we state it? Let's have conclusion number 2. The variance of the sample means is less than the variance of the population. The last one. Let's solve for the sampling error. What's a sampling error? The sampling error is a difference between the mean of the sample and the mean of the population. We say the mean of the population is the true mean, and the mean of the sample is the one from the sample, right? Because here's how it works. Remember I told you yesterday that it's very impossible to take a data from the population. So what do? We only take a sample. We only take a sample to represent the whole population. If we will solve for the whole population, it will get a mean, the population mean. And this is just our sample mean, the means of the sampling distribution. How sure are we that this one best represents the population? What's the degree of the error? Example, if all grade 11 students will take the NAT, the target might be a population mean of an 85 score in math. But I only took the sample from MVCA. Not everybody had a chance to take the test. And it has a sample mean of 80. Now, what's a sampling error? It has an error of 5 points. That is where we need to have our sampling error. Now, how do we compute for the sampling error? We have the sample mean You have this in step 4. We subtract it by our population mean. That's it. So 1.5 minus 3, that's negative 1.5. Up to the last. 4.5 times 3, that's positive 1.5. So how do we state our conclusion? We cite the range of the sampling error. It means that the sampling error ranges from negative 1.5 to 1.5 based on the population mean of 3. Now, do you have any questions before